right, welcome to my class. As I was telling I showed you earlier how to have 2-catenane. Now, 3-catenane, how you going to have is like this. Three-catenane, I 3-catenane, first I take this phenanthrolene and then we make phenanthrolene derivative to make this particular, make this not here. See, I have to draw right because these are actual synthesis carried out. Okay, so here is a macrocycle, oxygen, oxygen, 1, 2, 3, 4, 1, 2, 3, 4, and 6. Once you make these macrocycle, then we give this diphenol and copper salt. Okay, this is a BF4 salt. Okay, so this will make copper. Let me draw now this diphenol. What is this diphenol? This diphenol is nothing but okay. I just this diphenol. Actually, I should be writing double bond like this, but this is also okay. Okay, so this is my diphenol. I use this diphenol and the macrocycle along with copper MECN. So, you get now I am going to make a cartoon. We do not have time to write so much and you understand now. Okay. So, this is a dihydroxy and this one is that macrocycle, this macrocycle. Okay. Followed? All right. Then another one will come here. Okay. Another one will come here, same thing. Little bit bigger, let me write. Okay. Yeah. And then OH. OH. Then we can react it with, we can react this with, well, Sauvage and his group did that. In presence of cesium carbonate, a weakly basic, DMF as solvent, and this compound bromo CH2 CH2O CH2 whole N CH2Br, N equal to 2 or 3. So, this one now reacts, this chain will react here, and what it will form? Minus H2O, that will take care of by, okay. So, we get copper, and then we get this compound. This is my spacer. So, once we remove copper by treating it with potassium cyanide excess, we get 3 catenane. So, basically this group could make catenane of this kind, many. So, those examples I am writing here, cartoon, only cartoons. These are metal, copper 1, then so you just look at these marvelous structures, we will find uses of these, discuss. And these are all realized, it is not that just I am writing. These compounds are all realized, 1, 6 I am writing, 2, 3, 4, 5, 6. So, very interesting looking molecules could be synthesized by using the coordination tendency of copper 1, okay, copper 1, and it was done all high dilution technique, and very easily copper 1 has a strong tendency to make this molecule to make tetrahedral coordination. Okay. So, now how about without using any metal? So, that is what I am doing. I am showing you the some of these, just give me a moment. I will be showing you these all I have taken care of. Now, I will show you catenans. Come on, quickly. Okay. What you do is, this time our guiding principle is not the coordination tendency of the metal ion, but we are taking the help of pi stacking with pi rich and pi, electron rich and electron poor pi systems. So, let me draw some of these, and why this was done by Sauvage, this particular compound, suppose this one, okay, I found it, I got it, hang on, okay. What you take? You make this macrocycle. So, now I am showing you how to make catenan without the use of metal ion, but using pi stacking properties. With the electron rich and electron poor, we can get this, all kinds of problem. Okay. See, I have to do this because this is kind of exactly how he made it. So, I have to write 1 and 1, okay, and another. So, here is 1, 2, 3, 4, 5, 1, 2, 3, 4, so 5 oxygen, and I come here, oxygen. So, here 1, 2, 3, 1, 2, 3, 4, and then this one is 5. Okay. So, this macrocycle, this is sort of electron rich pi stacking, because electron oxygens are there, they can also donate electrons and all that. Now, we take another unit, let me draw, we take another unit, that unit looks like this. Okay. Unit looks like all these things you have seen already, right? While we are drawing the 4,4 dash bipyridine, while we are drawing, oh, I see, I see, okay. Okay. All right. So, you take this particular molecule and I am taking another molecule. So, there are 3 molecules, they will react. Maybe I will write at the top. And what is the condition? Condition is in acetonitrile solvent. okay, at room temperature 2 days, and then you also use ammonium hexafluorophosphate okay. This is 1 and this is 2, ammonium hexafluorophosphate in water, you add it. So, what happens? You get this compound and then this binds here, it reacts and you form this particular compound. Yeah. Okay. Okay. Maybe I will go little bit shorter. This has become little bit bigger, so that's why all this problem. Okay. I am looking at the synthesis of this particular molecule. Okay, somewhat tedious all these things. All right. So, I will write this. Okay, then I write this one. This part I am writing N positive N, all right, N it's not very good looking, what do you call, drawing, but it conveys the message. Plus. So, you can understand that this particular macrocycle, this one enters here. Okay. This particular moiety will enter here like this. Why? Why it enters? It enters because this particular moiety enters like this. Why it enters? Because it is electron poor, positive nitrogen. So, it likes this oxygens and aromatics and all that, because they are electron excess, electron good. I mean, they are not poor, I should say, not excess, but they are not very electron poor, but this is electron poor. So, that is why they go in. Once they go in, then this particular moiety, reacts like this and make the catenane. So, it makes this catenane. This is the cartoon form of what I just made, and in this case no metal involved except that electron poor pi system, and another is excess. Okay. I mean is a not poor. So, poor and not poor, they interact pretty nicely and make a go inside, and then once you clip it, then you get the particular compound. So, that way there is a large number of system could be done. Let me now show you the cartoon that I made. Let me show you that, then it will be, we can appreciate how many of these compounds can be done here. So, what I have here? I have a macrocycle, and I have this part and this part. So, they go, it goes here, it is known as clipping. It's called, we can call it clipping. Once it is clipping, then what will happen? No. Then you get this particular molecule. So, this is also catenane, and we can make another way we can do it. For example, this is also known. And it is very easy for you to design these molecules now, not very difficult. Okay. Double clipping. So, this is clipping, and this is double clipping. Double clipping, and double clipping is double clipping. This plus this, okay. Maybe I will use a different color, probably that will be better. Let me see. Let me draw that. This, and double clipping means I will get little bit cumbersome. These things are little bit cumbersome to do it, but once you get a hang of it, it is very easy, no problem. So, with double clipping, I am going to get this. So, single clipping, double clipping. Okay. So, this way you can get, we can get another way also, we can make macrocycle. Oh, that one we made earlier. Okay. So, therefore, I completed this catenane things, and look, we have shown you how to make catenane. This thing will revisit again and again, and use this catenane for our different purposes, that is supramolecular chemistry. Okay. So, with using this synthon, now suddenly if I give suddenly this molecule, you will say where from you got this molecule. So, that is why I am taking trouble in giving you all these methods for having catenane or cryptan or macrocycle or spheran and so on and so forth. All right. So, in our this molecular knots and all that is done, I have come to the last group of molecules. So, here I will try. Okay. I have to make, let me see, I have to, first I have to write, and I have to write cartoon here. It is difficult to write cartoon, but I will try. Okay. Okay. So, it is not world's greatest photograph, but it is called trefoil knot. Trefoil knot. Trefoil knot, and how to make trefoil knot? So, trefoil knot is also made in presence of a metal ion only. Okay. You cannot synthesize a trefoil knot without the help of a metal ion as template. All right. And here again we use copper, okay, copper 1, tetrahedral copper 1. So, what is the principle of this molecule? The design is we have a rigid and flexible part together. So, here is a rigid part, here is a rigid part, okay. Okay, here is a rigid part, all right. Here is a rigid part. Okay, is a rigid part. And a flexible part, 1, 2, 1, 2, 3, 4. How many? 1, 2, 3, 4. 1, 2, 3, 4. Now, I get I will just time is not there, but I will just nevertheless I will try little bit. Okay, maybe next time I will do this molecule, this will take some time. So, I will tell you the principle behind it. This is a rigid part, and then you have flexible part, and then again rigid part. Okay. So, you synthesize a molecule like this, rigid part and flexible part. Flexible part is just an alkane chain, but the rigid part has metal binding sites. Okay. So, with this I stop here today. I will again start it from here on. Thank you.